Hi children, today in this session we will prove Pythagoras theorem.
In order to prove this theorem,
The only previous knowledge that we need to recall is AA criteria. That is, if the two triangles are equiangular, then their corresponding sides are in proportion. That is all about similar triangles which we have proved that theorem also.
here the corresponding angles are equal, then the corresponding sides are in proportion. I mean to say, AB and PQ are the two corresponding sides, then BC and QR are also the corresponding sides, and the third side is AC and PR, and also in the same ratio, that is the three sides are in proportion.
This is the only previous knowledge that we have to remember to prove Pythagoras theorem. Now, what does this Pythagoras theorem statement says? The statement says that in a right angle triangle, the longest side is the hypotenuse. The square of that longest side is always equal to the squares of other two sides.
Consider the triangle here, ABC. Give the name to that as ABC. Now the longer side here is the side opposite to right angle, that is BC. It is the hypotenuse. If the length of hypotenuse is 10 centimeters, imagine, and the length of the other two sides, AB and AC, are 6 centimeters and 8 centimeters. What is the square of the hypotenuse? 10 centimeters. It is 10 into 10. 10 tens are 100. Other two sides we have taken it as 6 and 8. What is the square of 6? 6 6 are 36. What is the square of 8? 8 8s are 64. So 64 plus 36 is how much? It is 100, which is nothing but the square of the hypotenuse BC. That is, let us explain the diagram by taking the side heading as data. So here the diagram considered is only triangle. The speciality in that is angle A is right angle, and side opposite to the right angle A is the longest side, and we have given the name to that as hypotenuse. So that is what data is. After data, next is the task, what we need to prove. Let's get back to the statement. In the statement, it says square of the hypotenuse is equal to sum, means add sum of the squares of other two sides. So refer the diagram here. The other two sides are AB and AC other than hypotenuse. Sum of their squares means AB square and AC square. Sum means AB square plus AC square is equal to the square of the hypotenuse, that is BC square. The symbolic way of the task assigned is considered. After this, the information given in the diagram is not so enough for us to prove this theorem. So what we will do is, as usual, we will go for construction. Construction is to the hypotenuse BC from its opposite vertex, that is right angle vertex, we need to consider an altitude. Hypotenuse, a line right angle with the hypotenuse from its opposite vertex, right angle vertex A. That is what the construction we are doing. Let us consider a line, and let me give the name to that as AM. So from the vertex A, right angle vertex A, I have drawn an altitude to the hypotenuse BC, and the altitude name is AM. So, and construction says AM perpendicular to BC is drawn. So with this construction, I got two baby triangles here. One is triangle ABM, another one is triangle AMC, and they are also right angle at the vertex M. Okay, so these are the extension that I am getting by doing a slight construction work here. Okay, now proof part. In proof part, for that we should go back to prove. It says AB square plus AC square. Am I right? Now we need to consider the two triangles wherein this AB square or AC square, anyone, either it is AB or AC. So consider the two triangles wherein AB is common. I think you are getting my point. The triangles in which AB is common is, one is ABC, another one is ABM. Very simple. So let us consider those two triangles, ABC and ABM, and we need to prove that the two triangles are similar. And that means I need to say that the angles are, corresponding angles are equal. Okay. To our observation, both the triangles are right angle. That means one of the angle is 90 degree. One of angle A is right angle, and as per our construction, angle M in ABM triangle is right angle. Angle BAC and angle BMA both are equal to 90 degree. Why? How do we know that these two angles are equal to 90? One is on the basis of the data, another one is on the basis of our construction. So out of the three angles, one of the angle we have proved here it as equal. One more we need to use A criteria, angle and angle criteria. One more angle we need. So look at the diagram. In both triangle ABC and triangle ABM, angle at vertex B is common. Correct? So let us consider that angle ABC in the mother triangle and angle MBA in the baby triangle, both are one and the same. They are common. So this is the another angle I am getting. So using A and A criteria, I can say that triangle ABC and triangle ABM are similar. Before that, let me consider the remaining angle also. So we have taken angle A and angle B from mother triangle ABC. So remaining angle is C. And from the baby triangle ABM, we have taken angle M and B. So the remaining angle is A. These two are the remaining angles. Let us consider the remaining angles also. So with this, I can say the two triangles are similar, that is equiangular. If the angles are equal using AA criteria, I can say the corresponding sides are in proportion. I told you the reason why these two triangles only we are considering, because these two triangles are having the common side AB. So let us find out that AB in the mother triangle and the same AB in the baby triangle also. That is, if you take A and B, the line joining this A and B vertex as one of the side AB, the corresponding side of this AB is MB. Okay. Similarly, from the baby triangle, if I take AB, the line joining this vertex A and B, if I am taking this, the corresponding vertices I should take is B and C. That is line joining the vertex B and C only I have to take. Are you getting? So keeping all those things here, I am writing AB by MB is equal to AB from the baby triangle at the denominator. And the corresponding vertices of A and B are B and C from the mother triangle I am taking, and reason for that is AA criteria. Now when we do the cross multiplication of this, what I'm getting is AB multiplied with AB is AB square is equal to BC and MB. Okay, so on doing the cross multiplication, here comes AB square is equal to BC into AB square is equal to BC into BM. Let me take this as the result 1 of case 1. So let it be equation number 1. Similarly, in case 2, I need to consider the two triangles which are having a common side as AC. Now look at the diagram and just figure out the two triangles which are having the common side as AC, and you will get the two triangles as ACB, the mother triangle, and another one is ACM. So let us consider those two triangles, and as we have proved in case 1, similarly we should prove these two triangles as similar using a criteria. Okay, as usual, angle A from the mother triangle and angle M, the vertex at A and M both are measuring 90 degree. Reason is given and construction. And one more common angle is here. Angle at the vertex C is common. So A and A criteria, angle and angle. So on the basis of that, I can say triangle ABC and triangle ACM are similar. Before that, let us consider the remaining angles also. With that, I can say the two triangles are similar. If the triangles are similar, using A criteria, I can say the corresponding sides are in proportion. How you should start? The common side we have taken here is AC. So consider the side having AC as common from the mother triangle and AC as a common side from the baby triangle. So taking those two measures, let us relate the corresponding sides here. AC from the mother, corresponding vertices of A and C are M and C. So AC by MC is equal to AC from the baby triangle. The corresponding vertices are BC. They are equal to one another. That is, they are in proportion on the basis of AA criteria. Now do the cross multiplication. Ultimately, we will end up with the structure AC square equals BC into MC. Take this as the result of case 2, equation number 2. Adding equation 1 and 2. Equation 1 is AB square equals BC into BM. Equation number 2 says AC square equals BC into MC. And adding 1 and 2, algebra comes into action. So like terms means we need to add, unlike terms means we cannot add those two things. Only thing is we need to just insert the positive sign between. As a result of that, at the left hand side I will get the structure as AB square plus AC square is equal to, at the right hand side, BC and BC are common. Let us pull out that BC as common factor, and the remaining factors are BM and MC, and insert the positive sign between them. Okay, that is AB square plus AC square is equal to BC and into BM plus MC. Then what is this BM plus MC is? Look at the diagram. When you add this, just when you combine this side BM with the another side MC, you will get a longer side here, and its name is BC. So I can replace this BM plus MC as BC, so that I will get AB square plus AC square equals BC into BC. Exponential form of BC into BC is BC square.
So with this, I can say that AB square plus AC square, that is the two sides of the adjacent sides of rectangle triangle, AB square plus AC square is always equal to the square of the longest side of the triangle, that is hypotenuse. In this case it is BC. So this is how the Pythagoras theorem we can prove. Thank you for watching.